AI needs data quality and data quality needs AI. That's what I briefly want to talk about. The first quote, AI needs data quality, is rather obvious, I guess. If you don't have good quality data to train your AI on, your AI models on, you're going to hit the garbage in, garbage out problem. So that is a well-known issue, and rightfully so. It gets an increasing amount of attention in everything AI and machine learning related. The second quote, data quality needs AI, might be a bit less obvious at first sight. Why does data quality need AI? Well, it's all about three aspects of what that we've discovered are very important if you want to do data quality, data integrity checks at scale. The first one is you need configuration excellence. You need to be able to make configuration easy, not just setting up the configuration, but also maintaining it. And that's where AI, and I'll show you in a minute, can be of great help. The second point is you want detection to happen at scale. It's not just about being able to detect at scale from a performance point of view, but also from a manageability point of view. You want your results to be accurate and robust so you don't hit an alarm fatigue problem, for instance. And the third point, it's actionability of the results. You want your results to be actionable for users. That means you need to cleverly somehow summarize things, for instance, to users. You need to take into account their feedback and incorporate that, and so on. And that's also an area where AI and ML can be of great help. So let's make it a bit more tangible. If I look at detection at scale and also configuration excellence in a context of stale data detection, for instance, you can take different approaches. And a naive approach would be a rule-based approach. It's not a bad approach per se, but it's less scalable in the sense that it might be easy to get started, but if you want to scale this, you're going to hit the problem of who's going to maintain those rules and keep them up to date all the time. You're going to hit problems with alarm fatigue, most likely, because your rules won't be perfect and they won't work perfectly on every measurement. And so you hit a situation like the one depicted on the left. That's what we typically see at customers. If you look at the time axis and then the bad actors here, you see that there's too many detections. This is not actionable. This is not workable. If you look at the middle picture here, that's the same scenario, but we've taken a model-based approach. We've kind of learned the behavior from the actual time series themselves to come up with more accurate detections and something that is easier to maintain at scale. It might be more difficult to set up if you're doing it yourself. We made that easy in times here, but it's more difficult to get started that way yourself. And then on the right side, you have a federated approach, which takes this one level further, where you're learning not just behaviors of individual sensors, but also of groups of sensors that are similar. And then you get a federated approach, which can, in some situations, even further reduce or improve the accuracy of the results. So this is where you're using AI machine learning on the detection side, but also on the configuration side, we leverage AI ML, recommending setups to customers, to users, based on the data they're working with and the use case they're interested in. So that's also something that can be of great help to scale things. We're also recommending specific checks. So if you do need a custom setup, you have lots of checks to choose from. We help selecting the right checks. We have some functionality that can help with that. That's another example. A third one would be more on the actionable results side, where you're looking at summaries of the findings in times here. We're creating logical groups. We're suggesting things in terms of commonalities that we observe. In this case, for instance, it's all energy measurements that have these issues of unit range violations. So we summarize these things already, so users don't need to go through the individual detections, but can be more efficient here. And the last example I wanted to show is more on the cleaning and on the cleaning side of things, where we also have functionality to, for instance, use AI ML algorithms to fill in gaps in data automatically in a clever way based on the behaviors of the signals. So those are all ways in which AI machine learning can help to do data quality at scale, and one of the reasons why data quality needs AI, much like AI also needs data quality.